Hi guys, today we are going to talk about nitrogen monoxide or nitric oxide, which is NO. So it is a colorless gas. It is very reactive molecule as it is a radical, in other words having an unpaired electrons. So here it has an odd number of electrons in the molecule. So nitric oxide is a heteronuclear diatomic molecule where it drew researchers which shaped early modern theories of chemical bonding. So first we look at the electron configuration for nitrogen. P3 for oxygen, which is 1s2, 2s2, 2p4. So the valence electron for nitrogen is 5, whereas for oxygen the valence electron is 6. So making the total number of electron for nitrogen monoxide will be 11. It is an odd number. Right, so we look at its Lewis structure. So first of all, consider a single bond between nitrogen and oxygen. So we've got 2 electrons here, and we've got 1, 2, 3, 4, 5, 6, and for nitrogen it has 3. So here the nitrogen will have 3 non-bonding electrons, whereas for oxygen it will have 6 non-bonding electrons. In other words, nitrogen having 5 electrons around the nitrogen, whereas for oxygen it will have 8. Right, so another structure for nitrogen monoxide can be considered having double bond between the nitrogen and oxygen. So still here we've got 3 electron, which is 3 non-bonding electron around nitrogen, and here which is 4 non-bonding electron for oxygen, making 7 electron around nitrogen and 8 or octet form for oxygen in this structure. Let us see the formal charges on nitrogen and oxygen for both of the structure, which is having 1 single bond and the other one which is having a double bond. Right, so formal charges on each of the atom can be calculated as valence electron minus the non-bonding electron minus the bonding electron divided by 2. Right, first of all, for N with 1, which is with a single bond, so the formal charges for nitrogen is its valence electron, which is 5, minus 3 electron, which is a non-bonding electron here, and minus 2 bonding electron, which is based on the single bond over 2. So we've got +1 here. Okay, the nitrogen will have +1. For oxygen, it will have 6 valence electron minus 6 non-bonding electron minus this 6, 1, 2, 4, 5, 6 minus 2 bonding electron over 2. So oxygen will have -1. Okay, so -1. So the formal charges for the nitrogen monoxide having 2 double bond is still having 3. So for the nitrogen here, the formal charges for nitrogen is actually having 5 valence electron minus 3 non-bonding electron and minus 4 bonding electron divided by 2. So here the charge is 0. So here on nitrogen the charge is 0. And for oxygen, the formal charge will be 6 valence electron minus 4 non-bonding electron minus 4 electron which is in bonding divided by 2, and here making the formal charge is 0. Okay, so this will be a good structure for nitrogen monoxide. Another structure for nitrogen monoxide is here, where it will have 4 non-bonding electron for nitrogen, whereas in oxygen is 3. So we can also calculate the formal charges here based on this structure. The nitrogen will have 5 minus 4 minus 4 over 2. It will have -1, so the charge is -1 here. And for oxygen, 6 electron minus 3 electrons non-bonding minus 4 over 2 is +1. So the +1 is on the oxygen. So it will have a resonance structure between these two. So here we can draw the molecular orbital based on the nitrogen monoxide. So here again we refer to its electron configuration, which is now will be the overlapping orbital 2p4. So we are going to illustrate based on these two orbital. Okay, first of all, we've got this is for nitrogen, this is for oxygen. So the interaction here will form the pi 2p and also the sigma 2p. This is the pi star 2p and sigma star 2p. So nitrogen having 3 valence electron and oxygen having 4 in the 2p. So we've got 1, 2, 3, 4, 5, 6, 7 electron. So 1, 2, 3, 4, 5, 6, 7. So this will be the molecular orbital, the illustration of the molecular orbital for nitrogen monoxide. Thank you. The electronic configuration for nitrogen monoxide can be written as pi 2p4 sigma 2p2 and pi star 2p1.